Hi everyone, my name is Abel Gray Katova. I'm from Greatest Design Consults. This is my WhatsApp contact. You can reach me on this number. You can call me on any of these numbers, okay? Today I'm going to be showing you how to calculate your part footing manually, okay? So you can check for that manually, okay? So to do that, let's come to our Protastructure. We have our columns here. Let's say I want to design the footing for column 14. But firstly, in order for this to appear or to display, you need to go to story 0. You can see I'm in my story 0. All you need to do is double click. It takes you to your story 0. Once you are here, you come to your display, go to interrogation, and then you come to your column display. You can see I checked on my axial load. So I want to know the axial load of this particular column. Okay, this load is what is acting on the footing itself. Okay, so I'm going to pick this particular load of 257.9. okay, as you can see is the highest here. So 257.9 is what I'm going to be using here to get my footing. Now all I need to do is to come here, let me explain this to you from here. So we are going to be assuming the size of the footing, and then the soil bearing capacity is actually given to us from the soil report. So the report will carry this particular one. So but for this purpose, let's say we are using 200, which is kilonewton per meter square, and then let's say our footing depth is 400. Okay, because we are designing just a one suspended floor. As you can see here, we just have just one floor at the top here. So in that case, let's use a footing of 400. If we use 350, it will serve within that range. Okay, from experience, we know that it will definitely serve. And then your choice of foundation comes based on the number of floors, based on the soil bearing capacity. That's the soil in that particular area will determine the choice of foundation that you should use. But let's say we are actually using the part foundation for this particular design, and then our soil bearing capacity here is actually at 200. Okay, so in that case, at 200 here. So in that case, the next thing here I'm going to do, okay, now since we have assumed our footing to be actually 400, the self weight of the footing, now we convert this to meters, because the density of your concrete is 24, which is in kilonewton per meter cube. Okay, so if you multiply this by this, now you punch that in your calculator, and so if we multiply 0.4 times 24, we're actually going to be having 9.6. So here I'll have my 9.6, which is going to be in kilonewton per meter square, because this is actually in meter. Okay, so if this cancels, you are going to be having this meter will take away one of this, you'll be having kilonewton per meter square. Okay, then our soil bearing capacity is in kilonewton per meter square. So let's say we are using 200, like I said, and then we subtract these, but there is the school of thought that believe in not really taking out this particular value, but let's take this out here. If we take this out, and then we are going to be having are going to be having 190.4, which is going to be in kilonewton per meter square. Okay, so we have the total axial load will now be, we are going to be using the service load. Okay, so anything multiplied by 1, that value still remains, it doesn't change. Okay, so total axial load is times dead load plus 1 times our life load. Okay, so the service load now, based on what we got here, our load, axial load here, it's actually 257.9 kilonewton. Okay, so we'll come back here, 257.9 kilonewton plus our life load, assuming this design based on the service that is going to be rendering, it's actually a residential building. Okay, so if it's a residential building, we know that from here, if you check for this, we'll be able to check for our life load for a residential building. It's actually 1.5. Okay, so here we have 1.5. If we add this up, we are going to be having 257.9 plus 1.5, which will be equals to 259.4. Okay, so now if that is correct, the area of footing, to get our area of our footing, all we need to do is to divide the axial load divided by the net soil bearing capacity, and we know that this is actually 259.4 divided by what we got here is 190.4. We are going to be having we are going to be having 1.36. Okay, so which is actually going to be in meter square. Oh, okay, this is the axial load, our axial load, yeah, which is 190 point all over our net load. Here is in kilonewton. Okay, and then our net load is actually in kilonewton per meter square. Okay, so by the time you do this maths, you are going to be having kilonewton and kilonewton will go with each other, and then all you have now, it will be in meter square. I hope you understand the point I'm trying to make. Okay, so if that is correct, this is what you have, and then so therefore, to get our length, it will now be, if we take the square root of 1.36, okay, that will actually tell us per length. So if you do that maths, if you take the root of this, we are going to be having our answer as 1.167. okay, so this is what we are going to be having. Our answer is 1.67, so which is approximately equal to 1.2. okay, so therefore it will be 1.2 since it is a square footing by 1.2, so this will be our size of footing. Okay, so this will be the size of our footing. So in order for us to do this now, let's jump right into our Protastructure and see what Protastructure is going to generate for us as our size of footing. So if we come back here now, this is the footing we actually calculated for. It is customary to pick some of these columns that you feel are actually going to be carrying like the critical loading. Okay, this ranging by eye, you know that will most likely carry a very high load because you are having a beam coming here, you're having another beam here, you're having another beam here. So you can just check and design for, you can probably design for one, and but it boils down to your experience in designs and all that. Okay, so you most likely see that that particular column will most likely be probably the most critical among them all. Okay, look at one here, this one is carrying a higher load. Okay, but for the sake of this tutorial, we are just designing for this. Okay, so if I right click on this and I click on insert part footing, now you can see what I'm having here. Now we need to check, you know, based on our calculation we use 200 as the soil bearing capacity, which is 200. So let's confirm that based on what we have here, if that is corresponding with what we have. Where is this? Nice, it's here. So let's drop this down to 200 and let's see what we have. Okay, now you can see it has failed. That 1.1 is failing. So here let's come back and see what we have here. Oh, nice. Now you can see this is telling us this is 1200 by 1300. You can see it's actually very close to what we just calculated for manually. Okay, now using the depth of our footing as 400, using the soil bearing capacity of 200, now you can see Protastructure has actually generated a 1.2 by 1.3 size of footing for us. So if you love what you are seeing, why not just like this video, just give it a thumbs up, subscribe to this channel, it's actually free. Click on the bell icon so as for you to get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. Okay, let me point out something quickly for you. You know, this place where we reduced, where we subtracted 9.6. okay, if you decide not to subtract this from it, okay, you are going to be having 200 exactly. So by the time you have 200 here now, if you divide 259.4 divided by 200, you are actually going to be having a lesser value here. So in most cases, most likely the length here is going to be lesser, so that means the size of your footing here is going to be lesser. Okay, and you can see if you try to type in that in your Protastructure, it's going to definitely fail. Okay, like you know, we have covered structural designs, mechanical and electrical service drawing, architectural designs, road designs. All are very much available on our YouTube channel. All you need to do is just to go down below the description of this video, visit the channel and actually keep yourself busy. Okay, make sure you stay safe and make sure you stay black.